Hello family, these are our solutions for Can You Do 63. Continuing on with what we've been doing with the Can You Do's for this unit, I am not showing you the solutions to all of them, but I do try to make it so that I do one that is similar to the one I'm asking you to do without solutions. So I think that that's very obvious if you compare numbers 55 and 56. This is one Can You Do where it will be, I shouldn't say one because they all are this way, but especially this one, you really want to give it a go before you just watch my solutions. You will get the most benefits out of trying it on your own once and trying to come up with something and then coming to the solutions to check your work and get the additional help that you need. Some of these we don't really need to discuss. I'll just show you. So for number 55, I don't think that we need to discuss it. 58, explain why it would not be wise to use a t-critical value to construct a confidence interval for the mean number of seeds produced by velvet leaf plants. So before I show you my solution, I'm going to get you started. So they're already telling you you can't use a t-distribution, you can't use a t-critical value, and you're just trying to identify why. And the issue is because our sample size is low, it's less than 30, so we need to use this histogram to determine if using a t-normal distribution is appropriate. Well, what we're looking for is strong skew or outliers. I'm feeling pretty confident that this guy is an outlier, so we need to use this histogram to determine if it is reasonable to assume the population is approximately normal. The histogram has outliers, so it is not appropriate to use a t-critical to calculate the confidence interval. So the idea here is when we take a sample, we want and hope that it'll be reflective of the population, and if it's a random sample, it usually is. So if you take a random sample and your random sample has outliers or is skewed to the right or the left, strongly skewed, it is a good indication that your population is also not normal. Okay, 60. 60 wants you to determine if you can use a T procedure. So on these ones, it is not saying whether or not you can use a T. You have to go through your conditions to determine whether or not you should use a T procedure. So the first one actually doesn't really apply to checking conditions because we have the ages of all of the U.S. presidents. We know the population is manageable, so we don't need to estimate the average age at death. We can just calculate the average age at death. So a T procedure is not needed. We have the measurements for the entire population, so we don't need to estimate average age at death. We can actually just calculate the true value. B, a T procedure is not appropriate because this is not a random sample. AP statistics students do not represent the entire population. So in this case, we would check our conditions and the first condition is not met. Random condition is not met. And then C, we can use a T procedure. So A and B, no go. C, yes, because a random sample was taken, N is greater than or equal to 30. So even though this shows strong skew, CLT applies and we can go ahead and use T procedures. So even though this shows strong skew, N is greater than or equal to 30, so we are allowed to use T critical. And then lastly, N would be all words in the medical journal, so it's definitely reasonable to assume there's thousands, if not millions, of words in a medical journal. 61 is one that you probably need help with before you can do on your own. 61 and 62 are very similar. If you could not do 61 without this solution, don't worry. Just write it down, make sure you understand, and then have it in your toolbox moving forward. So, this wants you to interpret the value of the standard error in context. So, if we take many samples of size 27, the sample mean will typically vary by about 1.79 from the population mean. So I left out some context just so that it was a little bit easier to understand standard error. But essentially what standard error is how far off are we from the true value? About how far off will our samples be from the true value? I'm going to say that one more time. About how far off will our samples be from the true value? Now this doesn't have units, so there's no units for me to write, but the interpretation is if we take many samples of size 27, the sample mean blood pressure will typically vary by about 1.7898 from the population mean blood pressure. So down here, where it's asking you to do the same for commuting times, you will calculate your standard error, and you will start with, if we take many samples of size 20, the sample mean commute time will typically vary by about blank minutes from the population mean commute time. So, hopefully that was helpful. 67, looks like I'm trusting you to do 67 on your own. 69, we actually have to use our calculator to put the data in, make a graph to see if a T procedure can be used, and then construct our interval. So we are estimating mu, the mean fuel efficiency for this vehicle, or vehicles of this type. We are going to do a one sample T interval for mu. That is necessary for full credit on exams. My average is 18.48 and my S is 3.116. I got this by using my calculator. The buttons that you press in your calculator are Stat, Calc, one variable stats. So Stat, Calc, one variable stats. Then in this list of one variable stats, I personally like to use the 5-number summary because it's given to us with all this other information. So I made a box plot using the 5-number summary. There are no outliers, and there doesn't seem to be strong skew. I mean, the left-hand side is a little bit longer than the right-hand side, but it's definitely not strong skew. So I did all of this first, entered all this data into the calculator, used one variable stats to get my X bar and my S, and then used the 5-number summary, min, max, Q1, Q3, and median to to graph this box plot. You could also do a histogram or a dot plot, but I think this is the fastest. Here is my formula for the confidence interval, and I use the formula to remind me what I'm checking. So X bar just reminds me to verify on my own, because it's not required for full credit, that my sample was random. And yes, it was a random sample of 20 20 of the records for the vehicle. Do not say it was an SRS. It was not an SRS. Family, this was not an SRS. It was a random sample. A T procedure is appropriate because the box plot of our sample does not show any obvious skew or outliers, so it is reasonable to assume the population is approximately normal. Make sure that you have the word approximately. Approximately. You will lose points if you say normal. You have to say approximately normal. N is all vehicles equipped with computers. You could also say all vehicles of this type. So it is reasonable to assume that 20 is less than 1/10 of the population. This is my point estimate. This is my T critical value. This is standard error. I get a lower bound of 17 and upper bound of 19. And this is my conclusion. Any questions on this? Ask me before class, during class, email me, whenever works best for you. 73 and 74 are next lesson. This is the last lesson that we're doing, so skip 73 and 74. 75 you can do without me. 76 you can do without me. 77 you've actually already done. It was the lesson quiz for part 1. So it says a quality control inspector will measure the salt content in a random sample of bags of potato chips. Which of the following would result in the smallest margin of error? Well, the only thing that we can find, given this information, that has to do with margin of error is our T critical. You could think about your sample size like a sample size of 50 is going to be better than a sample size of 25, but I would look at your T critical value. So I actually had you calculate these 4 T critical values, and by calculate I mean find, in lesson part 1. So these are the T values that match this info. For N equals 100, I found the, I think it was the smallest. So I just came to 100 and looked at the critical value. And eventually the numbers got big. So 2.6, 2.8, 3.1, 3.3. So what I'm selecting here is the smallest critical value. The smallest critical value will result in the smallest margin of error. So the smallest one is 1.684. Once you get to 99% confidence for 100, you're at 2.6, which is bigger than all of these. And then after 99%, it just keeps getting bigger. So this says N equals 100 at any confidence level. Well, that's not true. At 99%, it's too big. So it has to be B as in boy. And then what of the following would cause the most worry about the validity of a confidence interval that was constructed? Well, if there is a clear outlier in the data, and they mean a clear outlier in the sample of 24 rats. So in the sample of 24. Stem plot shows mild right skew, that's fine. You do not know the standard deviation, that's fine. The population distribution is not exactly normal, that's fine. None of these are a problem when using a T interval. Nope, this guy is. You cannot have outliers. Okay, that's it. As usual, send questions my way in any way that you feel comfortable with. Love you guys.